Bismillah, Assalamualaikum. This is statics tutorial on composite areas. Now, when we talk about composite areas, it can actually be related to centroid, which is from chapter 9, as well as it can relate to moment of inertia, which is from chapter 10. And individually, we already have the lecture videos as well as the tutorial videos for each of these chapter individually. So you can take a look at the videos in the playlist in the description box below if you haven't, or if you are unaware of that. But this video is basically we are putting both chapter together, because in the final exam the question can integrate both centroid and moment of inertia together. And more interestingly, it can be dependent on one another. For example, in some final exam question, you will be asked about moment of inertia with respect to the axis of the centroid. Hence, if you make a mistake on one part, it will affect the other part, right? So that is the type of question that can come up in the final exam, and this particular video will address that. Right. In terms of the question that we will be covering in this video, the PDF, you can find it in the description box below as well. And basically this video will have three main parts. And if you see the timeline here, you can see the three main parts, right? So if you feel you want to jump straight into any of those parts, feel free to do so. The first part, after the introduction of this video, basically is going to be the overview that you should already have understood by now, but it is more of a revision of how to calculate either centroid or moment of inertia if, for example, you have to refer to the table, because for composite areas, normally or most of the times it will relate to what you can capture from the table, right, given. That's the first part, and the other two parts is basically just two examples that we will cover to help in terms of understanding how to actually go about in terms of the operation of the calculation, inshallah. So without further ado, we'll go to the first part. So first, the overview of the understanding that you should already have in you after covering both of the chapters. Just a brief revision, inshallah, right? So when we talk about composite areas, what it means is basically it is an area which is a combination of many different basic shapes. For example, if you have for example, this is a composite area where we can divide it into many different basic shapes. For example, this one rectangular, and then you minus this one, and then this one is a triangle, and then this is a rectangular or a square, depend on the dimension, and this is a quarter circle, for example, right? So just an example of composite areas. It means basically it is an area that is a combination of different basic shapes, basic areas, right? So it is just that. And then you also have a table, right, of geometric properties of area elements. Normally in your textbook, it is at the back cover of your textbook. That's the normal placement of that table. And hopefully you understand, if you look at the tables, there are maybe one or two tables depending on your textbook, where you actually have three different elements. One is not three different elements, three different types of elements. One is basically just a line, right? Second is area, and we are focusing on area in this video. And third is volume, which is basically 3D shapes, right? Or 3D volume, basically, right? So make sure you understand that when you look at the table, normally between area and volume, it's quite obvious, right? You can see the table. You can see this is basically area and this is volume. It's quite obvious, but sometimes the table actually combine for the area as well as the line on top, right? So make sure you understand, okay, this is for line, this is for area. Do not mix them up. All right. And taking a look at the table, maybe we'll just display it briefly here. the table. This is an example of a snapshot of you know, 4 basic shapes that we tend to see, right? We have this the semicircle, we have the rectangular, we have the circle, and we have the triangular area. So this is just an example. Normally the table have more how to say type of areas that you can see, right? So if you look at it, normally the table give you 2 different equation or information, right? One is about the centroid, second is about the moment of inertia, right? So for example, if I'm just focusing on one example right now, oops. So let's say you see the rectangular one. So I hope I can put it there. You can see the rectangular one, and then the information of the centroid is basically in the diagram itself. So you have the center marked as C, and then you have the axis X and Y. So that indicates that if you have a rectangle, the position of the centroid is basically at the middle. That's the easy one, right? Similarly, if you look at a circle, so hopefully I can put a circle there, the centroid is at the middle, and then the axis that goes through the centroid is as drawn. If you look at a triangle, so hopefully I can put it there. This type of diagram actually shows the centroid with respect to only one axis, right? And we will discuss a bit on that, because if you remember back just now for the rectangle and the circle, because it is symmetric, then it's quite obvious for both angle, right? It's center here and a center here. But for triangle, if it is a right angle triangle, something like this, then it is obvious, right? So if you look at the diagram there, you can see from the height it is 1/3 of the height, right? But here, because this is an example of a right angle triangle where this is 90 degrees. So if you have, let's say I'll name this B, I name this H, for example, right? So we know that this length here and this length here, oops, is basically, this is 1/3 of this length, and this is 2/3 of this length. Similarly here, right? This is 1/3 of this height. This is 2/3 of the height, right? Maybe I should write it like this to avoid confusion, right? Okay, so this is if it is a right angle triangle. But if you look at the table there, or a portion of the table there, what happens if it is not a right angle triangle? So for example, given there is something like this, for example, right? Now in this case, we can only determine that this is a portion of 1/3 and 2/3, right? This height, right? But the position in the x-axis is unknown. Why? Okay, we will discuss why. Now, because this one actually we can divide into 2 right angle triangle, right? So it will have this portion here becomes something like this. This portion here, it becomes something like this, right? And given here, you can know that this is, the ratio is 1/3 of, how to label this? Let's say this is B1, B2, but of course this is the same height, right? So this is 1/3 of B2, this is 2/3 of B2. This is, if you have the point here, so this is 1/3 of B1, this is 2/3 of B1. And the height is basically, okay, the color is, okay, so this is 1/3 of H, right? And it's the same here, right? Hopefully it's not too small, hopefully you can still see. And this, the other is 2/3. If you combine this, taking the average, basically, average meaning you have to do like what we have in the table, right? Hopefully you can recall back what we have covered in the lecture and the tutorial with regard to centroid. So because it's not just average directly, it is just you have to multiply by the area, right? But anyway, because this is exactly the same, so it will end up resulting is just 1/3 of h. But this position, it will not be at the middle here. It will not be here. In this case, it tend to be on this region, right? Because this have a bigger area, and this B2 tend to be bigger than B1. So it will shift to the right. The only possibility that it is actually end up at the line is when it is symmetrical, right? If this is symmetrical, then obviously it will be on this line, and then you know this one is 1/3 of the height. And if you break down like this, because this length and this length is the same because it's symmetrical, right? And meaning the length is the same, the 1/3 of the length is the same, the area is the same, so it will, when you combine it, it will be that in the middle there, right? So this is about triangle, right? So you have to understand how to use that diagram there when you have whatever triangle that you have in your question. So normally I would suggest just divide into right angle triangle, right? Do not use something like this unless it is symmetrical, right? Otherwise you only manage to determine only one axis of the position of the centroid and not the other axis, unless the question only asks for the vertical one. For example, if you do with respect to y-axis, then you can solve for this one, for example, right? Because you know 1/3 there. If you just want to have the x distance, right? But in this case, you will not know what is the y distance of the centroid. In this case, you do not know what is the x distance of your centroid, right? So normally the easiest way is just divide every triangle into right angle triangle. It makes things easy, right? Hopefully you understand that, because the table given is a more generic table, and you have to understand, okay, from that perspective, because the base is horizontal, then it's 1/3 upwards like that. But of course, if this is also vertical, meaning so you have 1/3 like that, or this one 1/3 like that, right? So hopefully you understand how to use the table, right? All right, so that is basically some of the elements that you can see from the table. And yeah, we only have touched upon the centroid just now, and then if you can see the moment of inertia, is just you can see that you have Ix and Iy equal to what, right? So I think that's straightforward, and we have discussed that when we discussed chapter 10. Yes, correct. Now, why is this table become important when you want to answer question, right? So again, we have information about centroid and information about moment of inertia. So we'll go one by one. So when we talk about centroid, finding a centroid of the whole area, you have to know the centroid of each individual area, right? In your table, for example, we'll start with the easy one, right? In the table, it will give you, for example, for a rectangular with the centroid there, so the axis x and y here, it will give you, where is the position? Okay, so I'll write it here, right? So Ix equal to 1/12 bh cubed, when this is b and this is h, right? And Iy is 1/12 hb cubed, right? This is what you can see from the table. Now, basically, if you understand how you get this, well, one, we have covered how to get this from the integration. But secondly is, if you know how things work, and if you are familiar how we do integrate this one, it is basically just one. If I just memorize for Ix, I can basically know what is Iy from the concept, right? For example, for Ix is 1/12 base times height cube. So for Iy, maybe I'll just tilt my head 90 degrees there, so I will see from this perspective So it is basically 1 over 12 this times this cube, right? Basically, because if I tilt my head like that, this become my base, basically this become my height. So this is valid for everything. For example, if you deal with triangle as well, because in the triangle, if you notice, Ix is only given with respect to x, basically, because Ix is x. It doesn't give you Iy, but if you want to understand, you just tilt your head 90 degrees. It's basically like that. For example, if you go for the triangle, it gives you, okay, we'll make it a right angle triangle, right? Because as I mentioned, it's easiest when you solve actual problem, make every triangle becomes right angle triangle, right? So let's say if I have this 3, 4, 5, right, for example. So from the table, you can see Ix, where x is here, y is here, right, at the centroid there. So is equal to 1 over 36 BH cube, right? So when I look from here, for example, for this particular geometry, so Ix is simply 1 over 36, and then I have base, which is 3, and then height, which is 4, and then cube. What about Iy? So basically you just tilt your head like that, so this become my base, this become my height, so it's just 1 over 36, 4, 3 cube. Right, so it is basically straightforward like that, right? So if you understand this, you can use the table even if the table only give you with respect to one axis, for example for triangle, right? But for other symmetric, normally it give you both, right? Okay, so that's how to use the information from the table. This is for the moment of inertia about its axis, right? So this is still, we are talking about the information in the table itself. Now, how we normally use, okay, so we'll discuss about that. In terms of how we normally use, right? So for centroid, when you do the table, right? So I'll draw the table here, for example. Then you have segment, which is each particular area when you divide it, and then you have x with, y with, and then, sorry, maybe I'll put area first. So the area of the particular segment, and then the centroid, x centroid, y centroid of individual area, and then x with a, with a, and then you calculate down there, right? You should be familiar with this by now. That I'm just want to relate with the information given in the table. So for example, we go the easiest one first. In the table, for example, if we go with rectangular, right? So rectangular, it gives you the information with regard to the centroid, right? If you have x, y, then obviously it at the middle there. Let's give this value, for example. Let's say this is 2, this is 4, right? The dimension of the rectangle. So the area is straightforward, 2 times 4. Straightforward. What is x width? Right, this is for this rectangular, right? What is this x width? Now, do not make a mistake of putting 2, because obviously we know this is 2 and the other, this one is also 2, right? But this one is a centroid. Centroid means it is with respect to, it's a coordinate, sorry. So coordinate is with respect to a particular origin and axis, right? So if the axis is exactly like that, then it is actually 2 and 1. But normally this area is somewhere, for example, if I have the axis is here, right? X, y. So to differentiate, we'll label this x prime, y prime. Now, if you look at the table, there's no such thing as x prime, y prime, because the table is always, the table given is always having the x, y axis going through the centroid, right? So that's one. But when we go into our question, so there will be a standard axis in the question, for example, right? So for example, there's a combination of shape and that particular triangle is there. So we label x prime, y prime, y, because later when we go to moment of inertia, you have this. For example, a parallel axis here, right? Ix equal to Ix prime plus a dy square, and Iy prime is Iy is Iy prime plus a dx square, right? So this we label x prime with respect to the x-axis going through the centroid of the shape itself, and this one with respect to the axis of the whole question. So we want to be consistent with that, so I'll label this like this, right? So x wave here should be the actual coordinate of this center, right? So if, for example, this distance is 2, meaning that x wave here is, because this is 2 and 2 becomes 4, right? So we have 4 here. Let's say this is, what is the logical 3, for example, right? So the centroid here, the y coordinate of the centroid of this shape is 3 plus 1, which is 4, and then you can calculate, right? So that's the thing. So make sure you understand, okay, the information from the table is exactly that, and normally for rectangular or circle you do not even refer to the table, right? Because obviously the centroid is at the middle there, right? So we'll try with a different shape, a triangle, right? So let's erase this. Let's say we have a triangle like this. Let's make it in a way that, yeah, like this, right? Let's say this is 3, this is 4, this is 5. Okay, from the table, so if we put the triangle table there, and normally of course the triangle as well, you already understand the ratio is 1/3, 2/3, even without looking at the table, right? So, but if you look at the table, the information is the same, 1/3 of the height. So in this case, you know the centroid is here, where this will be 1, this will be 2, right? It's 1/3, 2/3, while this is 1/3, 2/3, so this will be 4/3, this will be 8/3, correct? Or this one will be 1.333, this one will be how? 2/333, 2/666, right? Yeah, this is 1.333, this is 2.66667 if you round it out, right? Anyway, so what will be happening here? So area of obviously is the area of the triangle, so half of 4 times 3, right? That's the area of triangle. What about x wave? What is the centroid here in terms of coordinate? So it depends on the position of this triangle, right? So let's say this distance is 4 and this height is 3, for example, right? So x wave is basically the whole thing here, right? Which means we have to add 4 plus 8/3, whatever that value is, right? So if we go this 12, so 20/3, right? 4 times 3 is 12 plus 8 is 20/3. All right. Do verify, because I'm just calculating this on my head, and this is example is all like you know, it's not pre-planned. It's just I draw on the spot. So make sure if I make a mistake or not, right? But hopefully the concept is correct, but the calculation, I hope I do not make any mistake, but please do check, verify. What about the y wave? So it is basically 3 plus 2, which is 5. So make sure you understand that even if you understand, oh, the ratio is 1/3, 2/3 or whatever, do not straight away plug in the value here. For example, you plug in 8/3 or 2, because no, this is the coordinate with respect to the full axis, right? So we take another example. Let's say another shape that is not normally seen, which is a semicircle area. So if you have y if you have semicircle. Let's say it is here. Right, so let's say the radius is 2. If the radius is 2, so let's say we know the radius is 2, meaning obviously this is 2, this is 2, right? And this height is 2 as well. It means that. And let's say this distance is 4, right? And this height is it 4 logical? Let's say 4 as well. Right, so if you look at the table, I'll put it there. Because it is symmetric, so it will fall on this line. So we know it will be fall on that line, but the height will be 4r over 3 pi, right? So if you see the table, this is 4r over 3 pi. Am I correct? 4r over 3 pi, right? That's the position of the height of where the centroid is. Now, so what's the area? The area is half of a circle, right? So a circle is what? Pi r square, right? Pi r is here 2, right? 2 square. So it is half of a circle, so half, right? A full circle is pi r square. So this is half of pi r square. What about x wave? X wave here is quite straightforward because this is 4 plus another 2 because it's on that line, right? So 4 plus 2 is 6. Y wave is 4 plus whatever this is. In this case, r is 2, right? So it becomes 4 times 2 over 3 pi. So whatever that value is, so I'm just going to put it there. So it should be 4 plus, basically that's 8 over 3 pi. Like that, whatever that value is, right? So by now, hopefully you understand how to use the table for whatever shape that even I do not make an example here, but you know how to get this from the table, and then how to relate with the overall axis to give you x wave and y wave. So that is about centroid. Now we'll go to how about this moment of inertia. So again, we will start with easiest one, with rectangular first. So for moment of inertia, so Ix is that, Iy is Iy prime plus a dx square, right? So let's take a look at an example. So let's say this is xy axis, and then we have, let's draw it something like this, right? Let's say this is 2, this is 4, and we have distance here, for example, this is 4, for example, right? And this height is, let's say 2, meaning the position there, right? So from the table, you can see that about the centroid, which is x wave, y wave, basically, Ix is, so for rectangular, Ix is basically Ix equal to 1 over 12 bh cube. Right? Now, how to plug in this one? So we will do Ix first. So for Ix, okay, I'll make a distance here so that it's not confusing. So Ix is there, Iy is here. Right? So for Ix, for this shape, with respect to this axis, Ix prime is 1 over 12, b, which is 2, h, which is 4, cube, right? From here, bh cube. And then a plus a is basically, the area is basically 2 times 4, this is the area. And then dy square. What is dy square? Hopefully you still remember. It is the distance between the two axes, between x and x wave. So in this case, what is dy? Dy will be 2 plus 2, right? Equal to 4. So you will have here 4 square, right? Dy is basically the distance between x and x wave. So you have 4, because this is 2, 2. So this 2 plus this 2 becomes 4, right? So if you do this one, so IY, so even if I just memorize this one, so I can just look it that way. So this is my base, this height, so 1 over 12, 4, 2 cube, right? Another way is normally you can realize that it's just flipping the 2, right? And then plus the area is still the same, 2 times 4. And then what is dx? So dx is between y and y prime. So between this and this, right? So this is dx. So what it 4 plus 1, right? Becomes 5. Because this one is 1, this is 4, so it should be dx is 5. Do not forget the square. Okay, in your exam, do not forget this power, right? This, because sometimes if you forget that one, it mess up your whole calculation. And sometimes you understand, but in rushing you make mistakes. So please try and see if you tend to make that mistake. So if you tend to make that mistake, do precautions to avoid making this mistake in the exam. Alright, so that is for the rectangle. Alright, so let's try to see circular area. Circular area is straightforward as well, but okay, let's see. Now, if you have x, y, let's say the circle is here, and normally the distance is given to the center, right? So, for example, this is, okay, let's say the radius is 1. Let's say the radius is 1, and then this, let's say this is 3. This height is it logical? Is 2, for example. Okay. So if you look at the table for circular area, Ix is given as, so obviously you have x wave here, y wave here, right? And okay, in the table it gives you Ix, but in our relation it becomes Ix prime, right? It is 1 over 4 pi r power 4. 1 over 4 pi r to the power of 4. So when you do it here, so for Ix prime is basically simply this one, right? So 1 over 4 pi. So r here is 1, right? So 1 to power of 4. And then plus area is pi r square, pi 1 square in this case because our radius is 1. And then what is dy? Dy is again distance between x and x wave. So this distance is what? It's straight with 2, right? So you have 2 square. Okay, hopefully you still follow. What about this one? So circle is straightforward. Either direction is still the same. 1 over 4 pi r to power 4. So in this case 1 power 4. And then plus pi r square, 1 square. And then what is the dx? Dx is this one. Between y and y prime, it is 3. So 3 square. Oop. Right? It's not that difficult, right? Or it's not difficult at all. Okay? Right, so that is for circle. Now, hopefully you understand what is the context of understanding this, because when you have a combination of areas, actually you add on each individual Ix and Iy, right? So hopefully you remember that. So I'm just here because we haven't gone into example yet. We will coming for that next. But this is just to understand how to get from the table to apply it, right? So we'll just take it individual first. Okay, let's try another one. So let's say we have a different type of okay, let's say like this. Let's say like that, right? Okay, let's say this is 3, this is 4. And then the distance here, let's say this is 3, this is 2 to that, right? To this edge. Okay, so if you look at the table, you can know that obviously this is 1/3 ratio there, the position. And so if you have this x wave, y wave, so in terms of Ix with Ix prime, sorry, it will be 1 over 36 BH cube. 1 over 36 BH cube. Now, that's the information that you have. Now, so with the ratio, so we know this this height is 1, the remaining is 2, and for this one is where should I put it, 4/3, and this is 8/3, right? Alright, now so if you are calculating for Ix prime, so it is 1/36, b is 4, and then 3 cube, right? 3 cube, 1/3 bh, 1/36 bh cube from here, and then plus the area is half times 4 times 3, the area of triangle, and then dy squared is this one, right? So it should be 2 plus, what is this, 1, 2 plus 1, it becomes 3, so you have 3 square for dy square. Do not forget the square, right? And what about this one, iy prime, so 1/36, 1/36. If I want to just memorize this one, I slant my head, so this is b and h, right? So becomes 3 and then 4 cube. It's basically flipping this, right? And then plus the area is 1/2, 4 times 3, the same area of the triangle, and dx squared is between, I didn't label this, right, between y and y prime. So that whole distance is basically 3 plus 8.3, right? 3 plus 8.3, what do we get? 9 plus 8 is 17, so 17.3, right? 17.3 square. Do verify the number. So because it's 3 plus 8/3, right? Oops, this is 8/3, right? So 9, 17.3, right? So there you go. So the same concept, if you understand it, you just repeat the same concept with whatever area that you have. Now if you have understand this, then inshallah we are ready to go for actual example. Now I want to stress this, do not jump into example if you are still and do not really understand what's going on here, because this is the basic, and then when we go to example of a composite areas, it is basically applying what we know to the combination of shapes. But if for even one shape you don't even understand how to get the centroid of the coordinate of the centroid, or how to relate this and this, make sure you understand the basic first, right? So I think we have complete the revision of the understanding that you should have to be able to solve for composite area for both centroid and moment of inertia. We'll go for our example inshallah after this. So this is the first example. I'll put the diagram there, but hopefully you can also see the PDF, because for the full question, right? So the diagram is there, but the question is locate the centroid y bar of the beam's cross section area, and then determine the moment of inertia about of this area with respect to x and y axis. So there's two parts of the question. One is asking for the centroid, second asking for the moment of inertia. But if you notice, the moment of inertia asked in this question is with respect to x and y axis, and if you look in the diagram, x and y axis actually goes through the point centroid. So if you make a mistake in determining where the centroid is in the first part, you will get a wrong answer for the second part as well, because it is related to or using the value from the first part. So that is an example of how, if you understand about moment of inertia but you make a mistake about centroid, it still gives you a wrong answer, right? Okay, so let's focus on the centroid first, right? This area, I think hopefully you can still obviously see it is a combination of rectangular. And interesting for for shapes that is actually combination of rectangle areas, you can split it a different way, right? So I'll show it in one way, but if you divide it in different way, you just calculate accordingly, the answer should be the same, right? So in this case, if you just take the cross section area, it is basically, so I'll straightway cut the section. So it's combination of this with this with another this one, right? So I decided to cut it like that, right? Because why? I think this is easier because the distance is with respect to this, right? What is the distance to the centroid if you look at the diagram, right? So it's easier if that is the case for every shape actually touch with this line. If I cut it, I can cut it different way, right? I can make it this like this, and then this is shorter like that, but then this is not in touch with this one, and in terms of the calculation, I don't like that much, so that's why I divide it in what I did just now. So alright, so we'll redraw it something like this, right? Okay, apology for the bad drawing, but I think you can understand what's going on. Alright, is it in the frame? Yes, right? Now in terms of all the dimension, so we have all in millimeters, so this is 20, the height here is 200, this is also 200, this one. Now when this is, okay, this is 20, this is 20, because the whole is 80 and 80, which is 160, minus that one becomes 120, right? 120, 140, 160, right? And the height here is 20, right? This okay, this height 20, and this is also 200. Okay, right? So we have divided the area as such, and if you want to calculate the centroid, the easiest way is just using the table, right? So we have segment, and then we have the area, x wave, y wave, and then you calculate x a, y wave a, right? So let's label this, let's say, okay, to make it easy, 1, 2, 3. Okay, my marker is already, okay, 1, 2, 3, and 1 and 2, I think it will be replicating because the same area, the same geometry, and the same distance with the axis, right? So okay, now when we calculate, how to say, when we want to put the coordinate, it must be with respect to something, right? So let's use now, okay, the question itself, okay, I shouldn't do this, right? I don't need to. Okay, rewind back again, sorry. The question actually, if you realize, it only asks for y bar. Why is that? Because it is actually symmetric. So it's symmetric about this one, right? So obviously when it is symmetric, the centroid is on the symmetric line. So it is here, just we do not know where it is along this line. So in terms of x, we do not need it actually because it's obviously there, right? So we'll straight away go for y wave and then y wave area, right? So that's number one. Number two, still when we want to calculate the coordinate, we have to be with respect to something, and because the question actually asks what is the y bar from the bottom, so I'll use this as the bottom line, the coordinate there, right? Meaning the coordinate starts 0 here and move upwards. Okay, right? So segment 1, this one, area is basically just 200 times 20. 200 times 20 becomes 4000, right? 4000. Y bar, y wave, sorry. So the centroid of this should be at the middle, which is half, which is, then it will be 100 there, right? Half of 200, 100. So basically you multiply this one, you'll get 400,000, right? Segment 2, basically it will be repetitive because the area is the same, so it's still 4000. Y bar is still the same, 100, so it become 400,000 as well. What about shape number 3, this one? So the area is 120 times 20, so becomes, what is this, 2400. 2400. All right. The centroid is at the middle here, so it should be half of that 20, which is 10. Right, half of this 20 is 10. Then you get here is 24000. Right, and hopefully you remember what is the equation that we will be using after this. It is basically y bar equal to summation of y with a divided by summation of a. So you get the summation here and summation here. You plug in, you can get y bar. And the answer is, if you calculate, so do verify, the answer is 79.23. 79.23 millimeter. Right, so how do I get that? You just add this one, you get whatever value here. You add this one, you get whatever value here. Plug in summation of y with a, this one. Summation of a, this one. Plug in, you should get that one. Yeah, do verify that. Okay, so this is the first part. Meaning, what is the centroid? So it is somewhere here, right? So this is C, so meaning that, going back to the question, that will be x-axis and this will be y-axis. That we will use for calculating the moment of inertia, right? Because the moment of inertia is with respect to x and y, this one. So this distance here is very important, 79.23 millimeter, which we get from this initial calculation. If you get something else, or if you make a mistake, then obviously it will affect moment of inertia, as I mentioned earlier. Now, moving on to calculation of moment of inertia. Okay, so right now this is what we know, right? And in moment of inertia, so for because we have to calculate Ix as well as Iy, so hopefully you still remember Ix is what. Even if you don't remember, you refer to the table, you will get, right, 1/12 BH cube, right? And for Iy is the other way around, right? So sorry, this is Ix prime, right? If we refer to the axis of each individual area or shape, then you have the parallel axis theorem, Ix equal to Ix prime plus a dy square. That is the two equation that we will be using. Right? This is parallel axis theorem. In that you have the individual moment of inertia from the table, and in this case everything is rectangular, so straight away that one. All right, so the important information that we have to have is basically B and H, which is straightforward, we know it already, and also dy. Dy is the difference between the two axes, right? So normally I do suggest that you redraw it so that it is easier for you to follow and check your own calculation, as well as the examiner to understand what's going on. So we will draw it separately. For this triangle number 1, rectangle number 1, right, we have 20 here and 200, right? Hopefully it's not too small, hopefully you can see. Okay, the centroid of itself is here, right? And the centroid of this C of the whole thing is somewhere, if we related it, somewhere here, right? Somewhere here, right? Meaning this relate to this, so this point and this point, right? So this axis is x with x prime, this is y prime, correct? And if I draw in a different color about the centroid, this is x and y, right? So this is x, this is y, hence this is dy, this is dx. Can you follow? Right, the difference between the two axes, x and x prime, y and y prime. So we need those things. So so what is dx? So dx is basically, we refer back to this one, right? So obviously this is half of 20, which is 10, and the rest is this one, right, which is half of 120, which is 60, right? And then this height here to the centroid we have determined to be 79.23, while this height here is 100, because it's halfway of 200. So from there we can calculate dy, right? And of course dx is from here. Okay, if we go straightforward to the calculation, right? So should I do that, or should I draw everything? Do I have enough space? Okay, let's try this so that we know the continuation. This is not yet over because we have two other shapes, right? But when you do ix, so it is basically ix prime plus ady square. So ix prime again is 1 over 12 bh cube. For this one, it becomes 1 over 12, b is 20, h is 200, so 200 cube, right? And then plus a dy square. A is simply just 20 times 200 area, and then dy, right? So this one, what is dy here? It is basically 100 minus 79.23, should be 20.77, is it 20.77? Yeah, 20.77, 20.77. So it becomes 20.77, and then you have the square there from dy square. This is for ix. If I throw in straight away iy here, so from 1 over 12 bh cubes, but I'm looking at from this perspective, so 1 over 12, 200, and then 20 cube, and then plus 200 times 20, which is the area, and then dx square. Dx is what? 10 plus 16 is 70, so you have 70 and then square. I hope this is not too small. Hopefully you can still see, right? And I'm verbalizing everything, so hopefully you still can capture. All right, so this is for this part. Now going for this, okay, which is it easier, because I label 1, 2, 3 based on calculating the centroid, right? But now I think I'll erase this numbering. I think it's easier just to follow the arrangement here so that we do not get confused. Alright, so we'll take the middle here. So the area is basically here, like this. Down there, its own centroid is at the middle, and the centroid here is just above it, also in the middle, right? Right, here and here. So this will be x prime, this is x, this x, right? And because it's on the same line, so y and y prime is the same. Y or y prime is the same. Okay? Now with that, okay, the dimension, we have 120 here, and then 20 here. And what else? Okay, we have this height. Where to write it? Okay, this height to this x, the centroid height. Okay, what color? Okay, this one is 79.23, right? This whole height, but this height here is 10. Correct? Half of 20. So dy between the two, dy, okay, my red color is almost out. So dy will be what? Is basically 79.23 minus 10, which is 69.23, right? Dy. So is that? So okay, when we do Ix, for example, so if you have 1, 2, 3, it's basically, where to put it? So basically it is basically Ix equal to Ix1 plus Ix2 plus Ix3, meaning that is just additional of all Ix, individual Ix, right? So individual Ix for this shape is this one, from this, and individual here I put here, and then the rest there, right? Someone selling ice cream outside. Okay, so this one, so it is still 1 over 12 bh cubed, so plus 1 over 12, b here is 120, h here is 20, and then cube, and then plus a dy square. So a is 120 times 20, and then dy is 69.23, then you have square. Okay, I should put I think the separator here, so that you can differentiate between Ix and Iy, right? Otherwise it get confusing. Is my red color still visible? Hopefully you can still see this one. Alright, so that is for Ix portion. What about Iy for this one? So from here, then I plus 1 over 12, so I have slanted here, so you get 20, and then 120 cube, plus obviously this one, it will be 0 straight away, or if you want to plug in, you have 120 times 20, that's the area, but the distance is 0, and then you have square, right? That is if you want to plug in. Why is it 0? Because it's the same axis, there's no distance between y and y prime. And then we go for this one. So the area is on this side, so you have 220, and the centroid is on the left, right? So here is its own centroid. Okay, maybe I should bring it, never mind. So the centroid is here, right? This point C. So this one will be x prime, this one will be x, and then this one will be y prime, this one will be y, right? The value tend to be the same because the differences, because this is symmetry, right? So you will get basically if you are already calculated here, so it's quite straightforward. So this one dy is 20.77. Same calculation here. How do you get this? Basically 100 minus 79.2, and dx is basically 70 as well. So dx is 70, right? I'm not repeating everything because I assume you understand here, so it will be the same there if you go step by step. So in terms of the calculation, so Ix prime plus a dy square. So Ix prime is still 1 over 12, so plus 1 over 12. B is 20 here, H is 200 cube, and then plus A is 20 times 200, and then dy square is 20.77 square, right? For Iy, it is plus 1 over 12, 200 times 20 cube, and then plus 20 times 200, that's the area, and then you have the x square, which is 70, and then square. So what is the answer? So where should I put it? What is the answer for Ix for this question? It is basically adding all of this add to this, plus 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 plus, you should get, if you write it fully, it will be 417 00512, or this is millimeter to power 4, right? or 41.7 times 10 power of 6 millimeter to power of 4. 41.7 times 10 to power of 6. Right? 1, 2, 3, 4, 5, 6. So 41.7 there. So for IY, so I'll straight away write in terms of power of 6. So 42.35 times the power 10 power of 6 millimeter power of 4. 42.35, right? Or if you get the full is 4234666.7 millimeter to power 4. Right? So that will be the answer for this question. So for the centroid, we have determined earlier, which is 79.23, and then the first for second part, what is the moment of inertia about x and y axis, you'll get this one. Right? So hopefully you understand the process, and hopefully you understand the impact of, for example, if this is mistake, I'm keep repeating this one, right? But I'm concerned because it affects a lot, right? If this is a mistake, then you will notice that all this value, this one, oh, so okay, this one is not affected, but this one, and this one is directly calculated from this value, right? So it will be affected. Okay, so that's the easier example because everything is rectangular. So in the next example, we'll have a composite area where we have not just rectangular, and we'll still try to do the same thing, right? So to the next example. Alright, so this is the second example for this video. You can take a look at the diagram there, and of course from the PDF you have the full question. So we have basically three parts of this question. First, locate the centroid, which is the coordinate x bar y bar of this composite area. This should be straightforward because example like this exactly is covered already in the tutorial for chapter 9, right? So it's a repetition will be, but because this question have integrated both centroid and moment of inertia, so we have to show everything here, right? So first part, locate the centroid, and then determine the moment of inertia of this area about x and y axis. So meaning that you can see the diagram, you have x axis and y axis. So determine the moment of inertia about that axis. So this one is not affected by the centroid, because even if you do not calculate the centroid, you can still calculate this one. It is independent of the centroid, right? But the third part, next, determine the moment of inertia about the axis having the origin at the centroid of the area. Meaning this refer back to the first part, when you have located where is the centroid, determine the moment of inertia about the axis that goes through that origin of, or the origin is the centroid. Meaning what? Meaning that in the first part, we have the area like this, basically, right? So in the first part, we will determine where is the centroid. Let's say we will get the centroid somewhere here, right? So the second part, still you calculate moment of inertia about x, about y, no problem. But the third part is locate the moment, determine the moment of inertia about the axis having the origin, meaning the origin is 0, 0 of that axis, which is this point. So what is x and y here? What is the moment of inertia with respect to the x? So we have to label it differently. So let me say xc, yc, for example. Right? So meaning the third part means determine the moment of inertia about this xc axis and yc axis. So that directly related to your answer of this point C, because if the distance is a mistake, the result will be a mistake as well. So that's the three part. Let's solve one by one. So for the centroid, it's straightforward. You just divide the area, label it, and then do the table for the segment, right? So basically, let's redraw it, because in the exam you actually have to label it properly, right? And you cannot have an answer where you understand it but your examiner do not exactly understand what's going on, right? So that's the area. Basically you have 300 here and 150 until this 150 until this point, and then 150 there, right? Okay, so I have to then this until here, this until here, this until here, right? And then for the height you have 100 and 100, right? So 100 and also 100, meaning this is until here, this is until there, right? So let's label this. So I will say this is my shape number 1, number 2. Okay, really this is number 3. Okay, one information that is not written yet, which is the radius. This radius is 75 millimeter. All right. So how do we solve this? We just make the table and straight away calculate, right? So we have segment, and then you have the area, and then you have x wave, y wave. So x wave A, y wave A, right? So let's do one by one. So for segment number 1, which is this triangle, the area is simply just half times 300 times 200, right? Half times 300 times 200. So maybe I should write a different color so that it's not mixed up. What about the x wave? So we know the 1/3 2/3 ratio, right? So x wave is until this point, so it should be 200. Why? Because it's 2/3 of the 300, right? What about y wave? Y wave is 1/3 of 200, so meaning that 200 divided by 3, right? It's 1/3 of this height, which is 200. So 200 divided by 3. And this one, you can just calculate directly, right? Okay. So segment number 2, which is the rectangular, the area is simply, this one is what? 300. 300 multiplied by 200. That's the area. What about x wave? X wave is, because the center of this rectangular is exactly the same center of the circle, right? That's the middle. So x wave is just 300 plus 150, right? So 450. While y wave is just this height, which is 100. So again, this one is directly calculated. So this multiplied by this one, you get here. This multiplied by this one, you get there. And then area number 3, which is the circle. And the circle here is a hole, meaning that the area is negative. So you have negative area here, because this one will add to this one, but you have to minus this area of the circle. So the area is pi r square. So pi r is 75 square. Note that I do everything here in millimeter in the unit used originally, right? Okay, so that's the thing. Now some of you, I think some of the students prefer to convert everything to meter. No problem with that. Obviously it will become 0.3, 0.2, etc. So the number will be in decimal points a lot. This one, if you do in millimeter, you'll get a big number, right? Either way, but make sure when you do, if you convert to meter and you have a lot of decimal point, do not easily, how to say, round off too much. Because when you have decimal point, you tend to think it is insignificant, but it is significant if you because here, for example, you have 2 million or whatever, right? When you round off, you actually cut a lot of number, right? So anyway, so this one. What about the x wave and y wave of the center? Is exactly the same position as this number 2, right? So it should be the same value then. And then this one is calculated, right? Now what we need, okay, what is the equation? The equation is x bar equal to summation of x wave A over summation of A. and y bar is summation of y with a over summation of a. So what we need is, this is summation of a, this is summation of x with a, this is summation of y with a, right? So if you do this, you will get the answer. So do verify, you plug in, meaning you calculate everything you got, and then you should get, this one is 346.3. so this one is 346.3 millimeter, and this one is 86.17 millimeter. Do verify the number. Do verify the number in case any mistake took place. Right. So obviously, if you look at here, this plus this minus this one, and when you get minus here, multiply this one, this should be minus as well, right? And minus something multiplied by 100, it should be minus something as well. So you'll get this plus this, and then minus this one, this plus this minus this one, right? Okay, that's the value of the centroid basically. And you have to use this value for the third part of this question, right? Yep. So the first part is settled. This is how you calculate the centroid. Straightforward, just like what we have covered in chapter 9. No problem. Moving on to the next part, which is to compute the moment of inertia about x and y. Okay, so we are moving to the second part, and we are calculating the moment of inertia about the x-axis and the y-axis, right? So as normal, if you have seen my tutorial, I do have the tendency to draw it respective to the axis, so that everything is clear for your own benefit in terms of when you want to recheck if there's any mistake, as well for the examiner to follow more easily, right? So what I mean by that is I'm drawing the diagram, the shapes, respective shapes, as well as where it is in terms of the position with respect to the axis, right? So for this one, so we have three shapes basically. We have the triangle. So we have the triangle, and for the triangle, the axis is basically here, right? So we have y-axis here, x-axis here, right? And then, so if you draw the the centroid of the triangle, it will be there. So meaning that this will be x prime, y prime, right? And then you have the rectangular. Okay, so I have to make it a distance. Where the x-axis is there, y-axis is there, and the centroid is in the middle, so you'll have x prime, y prime there, right? And then we have the circle. Where you have x, y there, and then it'll be x prime, y prime there, right? Why do I tend to do this? Because it makes the the visualization of dx and dy will be very obvious, right? And we have the equation, right? So if you refer to the table for triangle, so for ix, for triangle is 1 over 36 bh cube, right? Correct. And for rectangular, this is ix prime. So ix prime here is 1 over 12 bh cube, and ix prime here is, what is it, 1 over 4 pi r4, 1 over 4 pi r4, right? And the universal of parallel axis theorem is basically ix equal to ix1 plus ix2. Okay, in this case, right, it will be okay, how to write it? because I do not label this, so I will just use the shape, right? Ix triangle here plus Ix rectangular here minus Ix circle here, right? Because in terms of the area, basically this plus this minus this one, right? Okay, so with that we can compute. Okay, what is the values then? So for this one, this distance is basically 1/3 of 200, right? So this distance here, this distance here is 200 divided by 3, and this distance here is 200, right? Is 2/3 of 300. This is 1/3 of 200. For those who are still confused where this come from, please watch the first part of this video, right, where we relate the table with the coordinate and so on. Okay, for this one will be straightforward. This one will be 100, right, the distance between the two axes, and this one will be 300 plus 150, which is 450, right? Okay, this is exactly the same. This will be 100, this will be 450. Now, do not, if you have shape like this, do not straight away assume it is the same. This one is because if you look at the question, the center of the rectangle and the center of the circle is exactly the same. But some question it is not, meaning that the center of the circle do not coincide with the center of the rectangle, right? So do not just because you have done exercise like this, you assume everything will be the same. It is, you go back to the actual question, right? All right. So we will try to do this, right? Meaning that you want to find what is Ix with this one plus Ix with this one minus Ix of that one. And for each Ix, where is it? Oh, I haven't write it, right? For each Ix, so for each Ix we have Ix prime plus a dy square. So for Ix of the triangle, you have Ix prime plus a dy square. Same here, right? So we'll calculate down here for these three shapes, right? So for Ix, for the first shape, Ix prime is 1 over 36 bh cubed. 1 over 36. B is, what this will be? 300. H, 200 cube. Right? And then plus a dy square. So a, the area is half times 300 times 200. And then dy is this one, 200 over 3. 200 over 3, and then you have square. Right? So that is Ix prime plus a dy square. And then plus for the rectangle. So you have plus 1 over 12 bh cubed. So b is 300, h is 200, and then you have cube. And then plus area, which is 300 times 200, and then you have dy square, which is 100 here, right? So 100 square. Okay, now it is minus, right? So minus Ix prime, which is 1 over 4 pi r, in this case is, what is r? 75, right? So times 75 to the power of 4. So in this case, because it's minus outside, so it's also minus here, a dy square. So pi r square, so 75 square. And then dy square, dy is 100, so we have 100 square. Right? So if you calculate this one, you will get, okay, I'm writing straight away in the number where it is simplified, right? 798.3 times 10 to the power of 6 millimeter to the power of 4. That's the answer. Right? If you calculate using your computer, you will get 798,343,924.5 millimeter to the power of 4. Right? So if you simplify, it becomes like this. That is for Ix. Sorry, that is for Ix, right? So for Iy, the same process, is just that we look from the perspective of y-axis. So for this part, for the triangle, so Iy prime, if you memorize this, you just shift your head like that. So this B and H, right? So 1 over 36, oh, you have 200 times 300 cube plus the area of half times 200 times 300, and then you have dx, which is 200, so 200 square, right? And then for the rectangle, similarly, Iy prime plus a dx square. So Iy prime is plus 1 over 12, so this and this square, so 200 times 300, sorry, not square, cube, right? And then plus the area, 200 times 300, this is the area, and then dx square, which is 450 square. Again, minus the circle, so minus 1 over 4 pi 75 to the power 4. The radius is still the same, and then also minus pi 75 square, and then what is dx, which is 450 square. If you calculate everything, you will get this value. What is it? 10.3 times power 10 power of 9 millimeter to the power of 4. Is it 10.3 multiply 10 power of 9? Right? Do verify the number. So the process is just like that, right? So if you are clear what is the position of each shape with respect to the axis, and hence you know what is dy and dx for each shape, and then you know the ix prime and iy prime for each, you know the ix is ix prime plus a dy square, and iy is iy prime plus a dx square, and then the overall is just plus and minus where you have a whole. Calculate, right? Okay, so this is the second part, which is straightforward. The third part should be straightforward as well, just that the difference is the position of the axis now make it a bit more complicated, because it will be, you know, at the middle of things, right? So we'll go back to the first part to take the position of the centroid that we have determined and use that for the third part. Now for the third part of the question, now relating back to the original diagram, but now the question says what is the moment of inertia with respect to about the axis that goes through the origin, or the origin now is the centroid of the whole area, and the centroid is what we have calculated. So basically what it means is, if I'm drawing it down here of the whole shape, right, we have determined that, because okay, the original distance, so this is 300 and this is 100, this is 100, and the whole thing is 200, right? This is basically the overall geometry. Now we have determined that the coordinate of the centroid of the whole area is, for the x coordinate is 346.3. So it is something here, okay, 346, right? 346.3. It is somewhere there. And y bar is 86.17. So it's not halfway, it's a bit lower than halfway. 86.17, right? So it will be basically here, somewhere there, meaning that what is where this is X and Y, or I label it, this is centroid, so XC YC, to differentiate with what we have calculated in second part just now, IX and YX, right? So that's the thing. So meaning that we actually will repeat the same process with the second part just now. It is just that the distance with respect to the axis will be different. So if we go one by one, so it will be, if you go the triangle first, so the axis is on the right side, right? So okay, the triangle, the axis is here. Okay, that's to somewhere here, right? But the C point is to the right and it's a bit below, right? No, sorry. Is it below or above? It is above a bit, right? Because okay, because this will be with respect to value, right? So this will be 2/3 is 200, and this height will be 200 divided by 3, which is, what is 200 divided by 3? It's 66, is it? $66.67, right? 66.67. Actually, it's 66.66666, right? Anyway, so but the centroid is above that, so 86, right? So the centroid is somewhere here, where the height is 86.17, and the distance here is 346.3, right? So this is where, when you want to, okay, so this will be X prime, this will be XC, if you use XC, right? And this will be Y prime, and this will be YC. So what will be the dy here? Right, dy here is basically 86.17 minus 66.67, right? Because this height minus this height, you get the difference. So 86.17 divide minus 66.67, you get 19.5. So 19.5. And what is the distance here? So that will be just 346.3 minus 200, meaning 146.3. 146.3. Okay? Of course, the 1/36 BH cube, etc., that still remains, right? But the difference now is dx and dy. Okay, so that is for the triangle. What about the rectangular? So for the rectangular, do I have enough space here? For the rectangular, the center will be here. So we'll have X prime, Y prime. The centroid will be within that, so somewhere here, right? XC, YC. The distance dy, okay. So okay, this one is, what is it again? 86.17. This one is 100, right? The height of it is 100. So the difference here is 100 minus 86.17, which means 13.83. 13.83. Right? So 100 minus 86.17, get 13.83. For the different here, So basically you will have, sorry, this is not 100, right? This is 150. I make a mistake. 150, 150. Is there another mistake? So 300, 150, 150, 100 and 100 becomes 200, right? Okay. So basically how to do this, from here until the centroid of this one, meaning from wherever you cannot see until here, it is 450, right? 450. But until this point here, until this point, it is 346.3. So meaning the difference here is 450 minus 346.3, right? 450 minus, so you get 103.7. 103.7. Right? So if you add this with this, you get 450, right? Yep. So that the x here is 103.7. What about the circle? So you'll have x prime, y prime, and then you have somewhere here as well xc, yc. Right, so if you notice that coincidentally for this one, because the center of the circle is exactly the same center of the rectangle, and the centroid is obviously the same for all, because both for the rectangle and the circle have the same centroid, so the distance will be the same, right? So this is 13.83, this will be 103.7, right? Hopefully you can still see that number. Okay, 103.7, right? Hopefully my writing is not too small. Okay, so I erase this one because we want to establish that from here, if all the value are correct, we can just proceed as what we have just done right now, right? So just to refresh, so Ix prime here is 1 over 36 bh cube, Ix prime here is 1 over 12 bh cube, Ix prime here is 1 over 4 pi r to the power 4. Is that correct? Yep. Now, so to calculate Ix, again, what we have is this triangle plus this rectangular minus the circle, right? And then for everything is Ix equal to Ix prime plus a dy square, right? So the triangle Ix prime, which is 1 over 36, okay, all the marker are okay. B is 300, H is 200, then cube, plus area is half times 300 times 200, the area of the triangle, and then dy square, which is 19.5 square. Next, this one, so plus 1 over 12, B is what? 300, H is 200, cube plus 300 multiplied by 200, and then dy we have 13.83 square, and minus the circle, so minus 1 over 4 pi r is 75 to the power 4 minus pi r square, which is 75 square, and then you have 13.83 square. So if you calculate this, do verify the number, you will get, what is this, 2613,19811.4 millimeter to the power 4, or 261.3 times 10 to the power of 6 millimeter to the power of 4. 261.3 multiplied by 10 to the power of 6. Okay, verify the number. Anything, put in the comment below if any mistake that you notice. Okay, for IY, so from this one, so it will be 1 over 12, 1 over 36. Oh, what it? 1 over 36, 200, 300 cube plus half of 200 times 300. This is the area, and then dx square, which is 146.3 square. Then for that one, so plus 1 over 12, 200 times 300 cube plus 200 times 300, that's the area, multiplied by dy, which is, what is this? 103.7. 103.7 square. And then minus for the circle, so minus 1 over 4 pi 75 to the power of 4. And then minus pi to 75 square, that's the area. And then the distance is again the same, 103.7 square. So if you calculate this one, to verify the number also, you get 167,244,8223 millimeter to the power of 4. Or if you simplify it, it becomes 1.67 times 10 to the power of 9 millimeter to the power of 4. 1.67 times 10 to the power of 9. Alright, so that's the third part. Now obviously the moment of inertia, if you notice, if you compare the second part of and the third part of this question, this should be smaller than the second part, right? Why? Because the second part, you have the x-axis and y-axis, the origin is outside of the area, while the centroid is actually in the middle of the area. So normally, because the distance between the area and the axis will make it, meaning the bigger distance, the bigger the moment of inertia is, right? This goes back to the lecture where we cover what is the meaning of higher or lower moment of inertia, right? So do verify the number. Anything, please comment in the comment section below. Any mistake, any suggestion, anything. And also take a look at the comment section below in case someone already notify any mistake, anything. You should take note of that. Alright, so this is two examples of how we compute centroid as well as moment of inertia with respect to different axes, right? In the second example, we calculate moment of inertia about two different set of axes, right? So that's the two examples. I think we will finish off with some how to say, reminder of if you see any different shapes other than, because sometimes in the exam the shapes given is different and student says, I have never solved this kind of question before. But you should not be affected by different shapes, because different shapes, we have covered two examples, right? Different shape, the method and the principle is the same. It's just that this equation may change, because for different shape, Ix prime and our prime is different. So, but it's not a problem, right? The full methodology is still the same. So I'll just highlight some of the possibilities, you know, as a conclusion of this video. So as a conclusion, we have covered a review of the basic concept that you should understand by now, related to centroid as well as moment of inertia, how to use the table and how to relate the table to our calculation. And we have covered two examples, with one is combination of rectangle, second rectangle, circle and triangle, right? But of course there are other shapes that we have not covered specifically in the example, but the concept is the same. If you have semicircle, if you have quarter circle, whatever, you can refer to the table and then you can capture the information there, relate to the whole bigger concept, right? Just as an example, right? For example, if you have, let's say we have what kind of shape? Something that is not directly like what we have covered before. For example, let's say we have something like whatever equipment here where for example we have rectangle here, for example we have semicircle here, we have circle here with a hole, and then what else, we have triangle here. How to draw a triangle, for example, let's see, right, for example if you have some shape like this, and then the question say find the centroid and find the moment of inertia about the axis of the centroid, or find the moment of inertia, because sometimes the question can give something like this. This is axis AA, find moment of inertia about axis AA, right? So do not think that this is like totally different kind of question. It's just the same, right? It's just that how we name the thing different. For example, we have X, we have XC just now, we have AA, whatever. So it's still just that axis located there. And what we need to know is just how each of the shape have the distance, meaning the dy, for example, with respect to that, and how to use parallel axis theorem, etc. Right? So sometimes the question say, okay, find the centroid first. So maybe here you find the centroid to be here, for example, right? It depends on the size of each this example. So and then find the moment of inertia with respect to the axis X and Y, for example, right? So all of this, if you understand what exactly is going on with our two examples and previously the overview, it's not a problem. It's just that then you have to divide. Okay, we have a shape of, let's say this is a rectangular, this is semicircle, this is circle, this is also circle minus, this is, okay, to make it easier to me, unless you only consider one axis, right? But if you have two axes, maybe this is one triangle, this is another triangle, and then this is rectangle. Okay, this is depend on how you divide, right? For example, maybe you take this whole as one rectangle, and then this one rectangle. You cannot take this and this, right? Because you will have redundant claim for this area, right? So if you take this whole thing, then you have to cut like that, and then you just do what we have done before, right? For example, for this circle, with respect to this axis over here, this axis, so what is this, etc. So the principle is the same. It's just that we can play around with whatever shape that we want, as long as you do not get panicked. You know, normally students tend to, alamak, what is this? Then they get panicked. Even though the concept is the same, it's exactly the same. Just divide, take every shape with respect to the axis. This is if I'm talking about, actually it valid for both centroid and moment of inertia, right? Because both is related to the position of the axis for the coordinate as well as dy and dx, right? So I just show some example where we can just surprise you with some shape that might frighten you, but if you come down, remember the basics, just divide and then do one by one. Okay, this one with respect to the axis, this one with respect to the axis, this one with respect to the axis, add together, or for centroid, do the table, no problem, right? So that's the final remark for today. Hopefully you will do well in your final exam, inshallah. All the best. You know, study hard, study smart, and pray to Allah, inshallah. May Allah make it easy for you. Thank you very much. May this offer some help, especially for those who, you know, before this, you know, kind of blur of how to do this kind of thing. Hopefully, I think it will help, right? Okay, thank you very much. All the best. Assalamu alaikum.